Greetings. This is ACME Chemistry team representing the International School for the 7th Chemistry Mexican Tournament. Our team is composed by Andrea Teresa Figueroa, Jesus Eduardo Montoya, Iris Barragan, and our advisor, Daniela Villanueva. We're presenting our solution to a problem, the ink of the future, bioink.
To start with, what is an ink? An ink is mainly a liquid with pigment. It could also contain some chemicals to control the density of the liquid, reduce the drying time, and allows it to last a longer time in the bottle or when applied to paper.
As we know, nowadays, inks surround us everywhere and at all time in our daily lives. The traditional inks contain volatile organic compounds and many heavy metals that are damaging the environment. These components go into waterways, generating water pollution. Not only that, but it's also really difficult to remove ink from water due to its chemical composition and how the ink dissolves into the water.
Since our objective is to develop a biodegradable ink that has a good adherence and can be made with organic household ingredients.
We decided to make our ink based on 5 main ingredients. Activated carbon, acting as our pigment, provides intense pigmentation and is chemically stable, meaning that the color will not fade over time and will last. Aloe vera gel, which acts as a colloidal stabilizer, keeping the carbon particles suspended in the liquid and preventing them from settling at the bottom. Honey. It's rich in glucose and fructose. This acts as a natural adhesive by forming hydrogen bonds with cellulose fiber. Its purpose is to lock the ink, acting as a natural binder. Water, vinegar. Water helps us with the fluidity, while the acid of vinegar helps us to preserve the other components on the ink, like honey and aloe.
Chemically, we have many reactions going on, but we like to focus on the most important ones to us. First, vinegar dissociates in water, stabilizing the pH of the mixture and functioning as a preservative at the same time. We also have the paper cellulose bonding to the sugars of the honey, creating hydrogen bonds, allowing honey to adhere to the paper. Honey acts as a hygroscopic, absorbing water to prevent the ink from cracking or from drying too quickly. Lastly, we have the polysaccharides, adhering to the porous surface of the activated carbon, preventing it from clumping and also acting as a dispersant. Carbon's high porosity allows aloe vera and honey molecules to physically anchor themselves into the pores. This creates a much stronger bond between the pigment and the binder, ensuring the ink doesn't just flake off the paper once it dries.
After selecting our ingredients, we needed to create a recipe. We believed that each ingredient composing our recipe will have an important role to the final product of our ink. Aloe vera will help with the consistency and prevent it from separation. Distilled water will be used as the main solvent and for absorption on the paper. Honey acts as a natural binder, creating a bond with the paper fibers. Activated carbon will work as the ink's pigment. White vinegar's acidity will help us to lower the pH and preserve the ink from organic decomposition.
We made different ink samples. After experimenting with the amount of ingredients in several inks, we settled for the following composition: 50% aloe, 20% distilled water, 15% honey, 5% vinegar, and 10% activated carbon. To determine the amounts for each ingredient, we use a rule of 3, where we multiplied the percentage we needed by the total amount of substance we wanted to make.
After performing our experiment and settling for an ink, we believe our hypothesis is partially right. Even though it worked out, we know that there is still room for improvement in different factors, such as the ink's consistency and how to give it a better adherence. Nevertheless, it's still a great alternative to take care of our planet. Although our ink seems basic at first, it still has the potential to last once it's applied. It is also important to mention that all of the ink's components are biodegradable and renewable. Each component has a function, like honey's adherence to paper, the activated carbon being used as a pigment, the water being a solute, the vinegar being used as a preservative, and aloe helping with the consistency and integrity of the materials. One main advantage of our ink is that it could easily be made at home and the ingredient percentages can be adjusted to reach new desired consistencies or pigmentation. The ink was made mostly with homemade methods, and the ink was mainly intended for it to be used on paper. The ink's recipe is not toxic, and is similar to traditional Asian ink recipes. It's important to note that certain ingredient quantities may vary according to the desired consistency of the ink, and that activated carbon particles might settle over time, so you might need to check the ink bottle before using it.
The ink's shelf life could last from a few couple weeks to a few months. Since the ink contains honey, water, and aloe, organic compounds are introduced, causing the potential growth of mold and bacteria. Despite this, once applied to paper, the ink could very well last for years. The activated carbon provides a strong color, and the honey helps the ink adhere to the surface. Since this is a mostly natural ink, the colors are prone to fade, especially if it's exposed to direct sunlight.
Now we have an ink that's biodegradable and renewable, since ingredients are all natural. You can also make the ink at home, adjusting the ingredients percentages to make the consistency of your liking. And with that, we wrap up the solution to bio ink, the ink of the future. Thanks for watching.